We have defined the slope of the tangent line, or the instantaneous rate of change of a function, in terms of a limit. Well, limits don't always exist. Sometimes they do, and sometimes we find out they don't exist. So, if that limit, that slope of the tangent line at c exists, then we're going to call it the derivative of the function at c. And that's what the derivative is. The limit as h approaches 0 of f of c plus h minus f of c over h. So one thing that you want to remember and be very, very clear from now until you die is that the derivative really is the slope. It does indicate the slope or the rate of change of a quantity. So the slope geometrically, the rate of change in application. So keep that in mind at all times. Even if you forget everything else about derivatives, always remember this part here. Now, so that's the formula for the derivative. That's what the derivative is. Okay. Now, what we can do is we can leave c as a variable. I mean, up to now I've said, well, pick a value c. I didn't really say which value of c. So for all intents and purposes, that c was a variable. Well, if we do that, we can change the notation from c to x, which is the normal notation for a variable, and we end up with m tan of x is going to be equal to the limit as h approaches 0 of f of x plus h minus f of x over h. And that is, of course, the definition of the derivative of the function f of x. And this is the one that you're quite familiar with. Now, there are several notations that we use in order to identify the derivative. M tan is not one of them. It's a notation that we only use to introduce the concept. But we're going to use most often the functional notation. So if we're starting from a function f of x, its derivative, which is obtained from or derived from the original function, is going to be denoted by f prime of x. And I'm sure you have seen that notation before. We're also going to use the short notation of just simply y prime. Remember, y is f of x, and therefore y prime makes sense. And that's a shorter notation that's going to be very useful when we play with derivatives within other bigger formulae. There is also another notation that you've probably seen before, and it's called the Leibniz notation, because Leibniz is the person who actually introduced it, and that's the dy over dx notation, or d by dx of f of x. dy by dx emphasizes the fact that what we're computing is a slope. It's actually the limit of a slope, but still intended to be a slope. And the second notation, d by dx of f of x, emphasizes the fact that the process of taking the derivative is something that we do to the function f of x. So we're going to be using any one of these notations, whichever one is applicable in any given situation. Now, a little bit more notation, or terminology, I should say. So if f prime of c exists, then we say that the function is differentiable at c. And on the other hand, if the derivative exists at every point in its domain, then f of x is called differentiable. Now, another little point about notation and the terminology, and that is that the process of going from a function to its derivative is called the process of differentiation. And so we're going to be saying that we're going to we will differentiate the function, and that we're differentiating the function. Please, 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 please do not use deriving. Okay, deriving is not a proper notation. I know that there is a computer program called Derive, which actually, among other things, also computes derivatives. Okay, but saying that you're deriving a function when you mean that you're computing the derivative is not appropriate. In fact, if you use that kind of terminology, you're simply showing to other people that you're not really that competent. On the other hand, if you use the proper word differentiating, then it gives the opposite and positive impression that you know what you're talking about. So make sure you always use the proper terminology and the proper notation when you're dealing with derivatives.